Hi, I'm Syed on Maths Online. Today I'll be dealing with the topic complex potential function. So, what is complex potential function? If I consider a function f of z is equals to this phi plus I times of psi. So this function f of z is called as a complex potential function, where this value of phi is called as the potential function, and this psi is called as the stream function. So we know that for a complex valued function f of z is equals to u plus iv. So if this function is an analytic function, it satisfies the CR equations. So the CR equations are of the form dou u by dou x is equals to dou v by dou y, and dou v by dou x is equals to minus of dou u by dou y. So these are the CR equations for this complex valued function f of z. So here also, if f of z is analytic, then it will satisfy the CR equations. So in this case, the CR equations will be, so you can observe here u and v are there. Here you have the functions as phi and psi. So accordingly you need to write down the CR equations. So you can see that in place of u you have phi, in place of v you have psi. So you have to replace u as phi and v as psi. So you get the CR equations to be dou phi by dou x is equals to dou psi by dou y. This can even be written in the form of dou phi by dou x can be written as 5x, dou psi by dou y can be written as psi y. Then the second equation is dou psi by dou x is equals to minus of dou phi by dou y. So this can be written as dou psi by dou x can be written as psi x is equals to minus of dou phi by dou y can be written as phi y. So these are the CR equations. Similarly, the derivative of this given function, as we know, f dash of z is equals to, so derivative of this function can be written as ux plus I times of vx. So in the same way here you can write down the derivative as f dash of z to be equals to, so this value will become 5x plus I times of psi x. So that's the derivative of the given function. Now let us take an example on this complex potential function. If phi plus I psi represents the complex potential of an electrostatic field where psi is equals to x square minus of y square plus x by x square plus y square. Find the complex potential Find the complex potential as a function of the complex variable z, and hence determine phi. So what is given to us? Psi is given. So let us write down. Given the value of psi is x square minus of y square plus x divided by x square plus y square. So this is the value of psi. So now let us try to differentiate this psi with respect to x and y. So differentiate psi partially with respect to x and y. So if I differentiate this with respect to x, psi x will be equals to differentiation of x square will be 2x. Here y is a constant, its derivative will be 0. Then plus you have x by x square plus y square. So it is in the form of u by v. So therefore you can use the quotient rule. So d by dx of u by v will be nothing but vu dash minus uv dash divided by v square. So if you use this quotient rule, this value is u and this value is v. So it is v into u dash x square plus y square into differentiation of x will be 1 minus u into, so u value is x into v dash. So differentiation of the denominator, x square differentiation will be 2x plus y is a constant, its derivative will be 0. It is whole divided by v square. So here it is x square plus y square whole square. Let us further try to simplify this one. So this 2x as it is plus you have x square plus y square, and it is minus of x into 2x will be 2x square whole divided by the denominator value will be x square plus y square whole square. So this will be equals to, it is 2x plus, so let me write down the positive value y square as it is. Then you have minus 2x square plus x square will be minus of x square whole divided by the denominator value that you have is x square plus y square whole square. So we have differentiated this psi with respect to x. Now further we'll try to differentiate this psi with respect to y. So we get psi y to be equals to, so derivative of this psi with respect to y, so x square is a constant, its derivative will be 0 minus of y square derivative will be, this y square derivative will be 2y plus, so once again u by v rule you can use. So it is v into x square plus y square into differentiation of this x with respect to y will be 0 minus u into, that is x into differentiation of this v, that is x square plus y square. X square differentiation will be 0, y square differentiation will be 2y. It is whole divided by v square. So whole divided by x square plus y square whole square. Further simplify this one. This will be equals to minus of 2y, and here if you try to observe x square plus y square into 0 will be 0. This entire term will be 0. So then here you have minus x into 2y will be minus of 2xy. So minus sign I will take outside. You will be getting 2xy divided by x square plus y square whole square. So we got the value of psi y. So we know f dash of z will be equals to 5x plus I times of psi x. I know the value of 5x, I have calculated it, but psi x value has not been calculated. What value we have calculated is nothing but your psi y value. So now we can rewrite this one using the CR equations. So using CR equations, that is 5x is equals to, and psi x is equals to minus of 5y. So these are the CR equations. Now I'll try to rewrite this f dash of z in terms of psi, because I have the values of psi x and psi y. So psi x is already known to us, so I'll retain this one. So I'll try to replace the value of 5x. So according to CR equations, 5x value is psi y. So therefore, your f dash of z value will be equals to, so 5x value is psi y. So it is psi y plus I times of psi x. So we have got the value of f dash of z. So let us try to plug in these values. F dash of z is equals to, psi y value is known, it is minus of 2y minus of 2xy divided by x square plus y square whole square. It is plus I into psi x value is known to us. So this is the value that we have calculated for psi x. So psi x value is known. So you can write down this value here. It is 2x plus y square minus of x square divided by x square plus y square whole square. So both the values have been plugged in. So now to find out the value of this f of z, I'll try to use the Milne-Thomson method. So what does this Milne-Thomson method says? So you have to put the value of x to be z and the value of y to be equals to 0. So we get f dash of z to be equals to, y value is 0, so the first term will become 0, minus, here y is 0, this term will also become 0. So this complete expression will become 0, plus I into, you have 2 times of x value is z plus y value is 0 minus x value is z, so it is z square divided by x value is z, so z square plus y value is 0 and it is whole squared. So f dash of z will be equals to, this term becomes equals to 0. You are left out with I times of, it is 2z, and this is plus into minus will be minus, z square divided by z square whole square will be z power of 4. You can cancel out this z square with z power of 4, you will be left out with z square there. So therefore you have I times of, it is 2z minus, you are left out here with 1 by z square. So this is nothing but f dash of z. Now to get the value of f of z, I need to integrate this one. Integrate this one. If you try to integrate, it is integral of f dash of z into dz will be equals to, you multiply this I with 2, so it is 2I, it is integral of z into dz. Then minus of, again you multiply this I inside, this I times of, it is integral of. So 1 by z square can be written as z power of minus of 2 into dz plus the constant of integration c. Integral of f dash of z will be f of z is equals to, it is 2I into, integral of z will be z square by 2 minus I into. So for this you can use the standard formula, x power of n into dx will be x power of n plus 1 by n plus 1. The standard integral formula if you try to use, so it becomes z power of minus 2 plus 1 divided by minus 2 plus 1 plus this constant of integration c. Or further if you try to simplify, this 2 and 2 will cancel out. So you have I times of z square minus I times of, this is z power of minus 2 plus 1 will be minus 1 divided by minus of 1 plus the constant c. This will be I into z square. This minus of minus will become plus I. Z power of minus of 1 can be written as 1 by z. So it becomes divided by z plus this constant of integration c. So if I take I common outside, so you will be left out with z square plus here you have 1 by z plus the constant of integration c. So we have obtained the value of f of z. So this is the first part of the solution. The second part is we need to find out the value of phi. So to find the value of phi, I'll try to replace this value of f of z in terms of phi and psi. I know f of z as phi plus I times of psi. F of z value. This expression can be written as I into, we know the value of z to be equals to x plus iy. So try to plug in the value of z as x plus iy. So you get x plus iy whole square plus 1 by x plus I times of y plus this constant c, or that is nothing but I into, this is in the form of a plus b whole square, so you can expand it, a square plus b square plus 2 times of a into b, 2 times of a into b. So I have just expanded this one plus this 1 by x plus iy, you can rationalize this one. So the rationalizing factor for 1 by x plus iy will be x minus of iy divided by x minus of iy. So this will be equals to I times of x square. So here you are having iy whole square, so this becomes I square y square. But we know I square value is minus of 1, so we will be getting minus of y square. So you can write minus of y square. Plus you can multiply, it's 2 times of I, so 2ix y. Plus here you can just multiply, 1 into x minus iy is x minus iy divided by, the denominator is in the form of a plus b into a minus of b, which will be a square minus b square. So it is a square minus b value is iy, so iy square, a square minus of b square. So further you can simplify this one, I into, this is x square minus of y square plus 2ixy plus, so this can be written as x minus iy divided by x square. So once again iy whole square will become I square y square, which will be minus y square. So that minus multiplied by this minus multiplied by this minus will become plus y square. Now I can just separate it. I can divide this x by x square plus y square and iy with x square plus y square. And simultaneously I'll multiply this I inside. So if you multiply this I inside, I'll be getting I times of x square minus I times of y square plus, if I multiply this I inside, it becomes 2I square. I into I will be I square xy plus multiply this I with this x, so ix. I'll try to divide this x by separately as x square plus y square. So iy is left out, you can multiply that one. So minus of I into I will be I square y divided by x square plus y square. Further let us try to simplify this one. So it is I into x square minus I into y square. I square value is minus 1, so it becomes minus of 2xy plus I into, it is x by x square plus y square. Here I square will become minus 1, so minus of minus will become plus y by x square plus y square. So we'll try to group the real and imaginary terms. So here the real term that you have is this expression and this expression. So you can write first the positive value, it is y by x square plus y square, then minus of 2xy. So this is a real term. Now imaginary term you can write, if I take I common, so you can write down this value, x square, here minus of y square, and here plus x by x square plus y square. So on the left hand side you have 5 plus I times of psi. So what I require is, I require the value of 5. So you can just equate the real terms. Equate the real terms. So you will be getting the value of 5 to be equals to, it is y by x square plus y square minus of 2xy. So that will be the required solution. So that's all I have for today. Thank you.